served as a sort of a cultural identifier for them. It helped them be proud of themselves as Athenians and to remember the rich tradition upon which their country was founded. And over the years, this ship, being made out of wood and living in a harbor with salt water all around it, started to rot and fall apart. And so over the years, they would take planks off the side of the ship as they began to rot and replace them with new pieces of wood. As the mast began to fall apart, they replaced the mast with a new mast. And eventually, some of the philosophers of Greece began to ask themselves a question. If all of the pieces and parts of which this ship was once made have now been replaced with new pieces and parts, can we really say that this ship is still the ship which Theseus sailed back from Crete? This is a philosophical debate, and one which is fairly interesting. What exactly does it have to do with content management and the Python language? I hope that by the time I finish this speech, you'll have a better understanding of exactly where I'm going with this. Before I continue, though, I want to give a little bit of an introduction to myself and to the topic that I'm going to talk about. My name is Cris Ewing, and I come from the United States, the city of Seattle in the state of Washington in the upper left-hand corner of the country. And I own a small consulting firm where I do Python web programming and customized trainings for clients across a number of different industries. In addition to my own consulting, I also do a fair amount of work for a company in Boston called Jazzcarta, where we build websites for larger companies than I can afford to interface with on my own. I also do a lot of training professionally, both for the University of Washington and its continuing or professional education programs, and also I am the founding instructor for the Python program at a company called Code Fellows, which attempts to teach people who are trying to switch to the profession of programming from whatever careers they currently have, how to become programmers and to share in this industry that we all love so much. Now I'm here today to talk to you about Plone, and I got involved with Plone about 10 years ago as a result of a project that I was taking on for the University of Washington's Department of Radiology. I'd been brought on board there to unify all of the different websites that they'd had into a single content-managed website, and we looked around at a bunch of different CMSs written in Python, written in PHP, written in Perl, written in Java, and the one that we eventually ended up landing on was Plone. The reasons we chose Plone were that it did a great job of integrating both images and text into single content objects. It supported the kind of diverse workflows that we needed in a very large institution with many editorial interests. Department of Radiology has lots of individual schools within it, and each one of those needs to have their own section of the website with their own rights management and so on and so forth. Also, Plone was a very secure website, and so it allowed us to have content that was inward-facing, that was designed only for the students or the professors, or even for people who were managing large budgets for research projects, to store the content that they needed to store in this website, and to store it in a way that ensured that only the people who were supposed to be able to see this content and edit it would be able to interact with it. So Plone fit a lot of the needs that we had, and I got involved programming Plone. Plone was very responsible for helping me to grow as a programmer and to become a professional, as opposed to the amateur that I had been up until that point. And it really served our needs particularly well. Since then, I've become very involved in the community. I served on the board of directors for a number of years of the Plone Foundation, and I've given speeches and talks and trainings about Plone around the world to various people. Now, in the talk that I'm going to give you today, I'll be wearing a number of different hats. By this I mean I'll play a few different roles in this speech. The first one will be that of the famous historian. I'm going to talk to you a little bit about where Plone comes from, the technologies that it's built on top of, and the history that led to the development of Plone. I'll also be wearing the techie hat. I'll be talking to you about the software that makes Plone work, how it's put together, and some of the new technologies that have gone into the development of Plone 5, which is the release that has just been made. Throughout, I'll be playing the part of a salesman, attempting to convince you that Plone is a project which is worthy of your attention and which you might want to consider picking up for projects that you might have that involve the content management space. And in the end, I hope to be able to play the part of the welcoming host and to invite you to join the Plone community and become part of the chorus of voices that make Plone work as a content management system. But to get ourselves started, I want to talk briefly about the beginning of time. The start of the internet, the ancient past, as it were, back when everything that we had came installed on these three-dimensional save icons. And back in those days, in 1996, this man, Jim Fulton, got on an airplane from Fredericksburg, Virginia, where his company Digital Creations was located. He was on his way to California to attend the International Python Conference. He was going to be giving a talk on internet programming and Python, and on his way he was doing, in the tradition of most conferences, his preparations for the talk that he was about to give, and studying the Common Gateway Interface spec, or CGI. Now, he wasn't really particularly happy with the spec. He didn't like the way that it was put together. It sort of upset him a little bit. And so on the way home, he played around with some ideas for improvements on the spec and began to write a piece of software that he called Bobo, which became the world's first web object publishing system in any language. Now, Bobo, along with two other packages, one called Document Template, which supported dynamic templating of content, and then another one called the Bobo Pause, which was an object database that later became the Zope object database. These three packages in concert formed the core of what Digital Creations called Principia, which was a commercial content management system. This disk here, I got a photo of this from Paul Everett, is a disk that they'd actually sold to the Department of Defense in the United States for an undisclosed sum of money, but I imagine it was a fair amount. Now, in 1998, the largest investor in the digital creations convinced Paul, who was at the time the CEO of this company, to release this Principia software, which they had created as a closed source project, as an open source library. Principia was renamed as the Z Object Publishing Environment. Digital Creations became the Zope Corporation, and the software Zope was born. Now, in the early years of Python, around the 2000s or so, Zope was actually really intimately tied to the development of Python itself. Many of the core contributors worked for Zope Corporation, and in fact, Guido van Rossum himself, our benevolent dictator for life, worked there between 2000 and 2003 when Python Labs became a part of the Zope Corporation. And Zope allowed developers a particular kind of magical special power. They were able to build powerful web applications entirely through the web without actually having to create any sort of file system code. This lowered the bar for getting involved in web development quite a bit. You could explore the system interactively, trying things out, creating things, deleting them when they didn't work, trying new things with a very low bar to entry. And so benefited from this low bar of entry, just like Python itself benefits from its very simple on-ramp. It's an easy language to learn, so it allows people to explore and interact with it very simply, which brings more people to it. And like Python itself, Zope was powerful enough and secure enough under the covers that once you had learned through this sort of experiential on-ramp, you were really able to build outstanding and powerful applications on top of it. Now, Zope was undeniably successful, and numerous applications were built on top of it to fill what was at the time a growing market for content management. The most successful of these was something that was called the Portal Toolkit, or the Content Management Framework, also called the CMF, that was architected by this gentleman, Cris Ewing. The CMF provided all sorts of great tools for folks. It allowed you to define content types through the web that you could then create instances of to set up pages or news items or things like that. You could control the publication of those across time using powerful and flexible workflows that managed rights and access controls for the content. You could set up display for the content by creating page templates through the web that would then be used to display this content in different ways. And you could even control interactivity by providing form controllers and Python scripts that your viewers or your users could actually interact with directly using HTML forms and so on and so forth. Finally, It provided the ability to design themes that were made out of aggregated folders of page templates and controller forms and all sorts of fun things like that, so that you could make the front end of your website looks very beautiful and attractive. However, as you can see, the back end of the CMF, where you actually did your authoring, was not a very attractive place. It wasn't a particularly inviting place for newcomers or people who were not, already technically adept. And so in 1999, this gentleman, Alexander Leamy, and this man, Alan Runyon, got together in a conversation in the Zope IRC channel and expressed a desire to create a new theme for the CMF that would provide access to the power that the CMF provided, but through a really attractive and easy to use kind of interface that would make it available to folks who were just ordinary users. CMF Plone was created to fulfill this goal, and it must have been a pretty good success, because after its first public release in October of 2001, Plone quickly gained users and mind share. Its most distinguishing feature was this idea that you could create content in your content managed system directly in the location in the website where you wanted that content to be. Most other CMSs work with this idea of a backend, where you go, you create the content, and then you design a place in the overall structure of your website where you want that content to live, and you say, make this thing appear there. Instead, in Plone, you actually surf through the website to the place where you want a page to be, and you press a button and create the page right there. You can manage the page right there, you can control access to it right there in the front end, and this allows you to separate that, or to get rid of that distinction between a back end and a front end. In addition, because it benefits from the same sort of strong security model that Zope has built into it, Plone allowed people and creators of websites to erase the difference between an inward-facing intranet that contained content that was designed only for logged in or authenticated users, members of an organization. They could erase the difference between that and the outward-facing extranet. The benefit of which is that you don't get as much repetition in the content that you're creating. You can create the same piece of content and make it used in a couple of different ways, which makes your content more dry. And we all know as developers that keeping things dry, not repeating ourselves, is a great goodness. Now, like Zope before it, Plone benefited from this mix of being both easy to learn and extremely powerful and flexible. The Plone community grew, and the software grew with it. This is around the time that I became involved. If you look in this picture right here, I think up in this corner, there's a guy right there who's wearing a little white baseball hat. That's me. And that's the first Plone conference that I ever attended, which was in the city of Seattle in 2006. The core contributors to Plone grew into the triple digits. Plone is a little different from other open source projects. Unlike Django or some other projects where there's a team of contributors who have what they call the commit bit, the ability to actually make changes to the core of the system, Plone only asks that you sign an agreement that says that you give up the intellectual property rights to the code that you write, and you have core access. You can begin committing, and so the number of people who contribute to the core of Plone is actually very large, up in the hundreds. The ecosphere of add-ons that were created for Plone burgeoned and grew. There was a collective organization that was developed using SVN, so that as you created add-ons, you could put them into a particular repository, and then anybody who had rights to that repository would also be able to help you maintain that. This sort of open access to the software that helped make Plone and make the extensions to Plone empowered the community to grow tremendously. And it meant that as you came to Plone, if you wanted some functionality for the website you were building, you were very likely to be able to find it. But there were weaknesses that were hidden underneath all of this strength. One of the issues is that Plone and Zope relied heavily at this time on the idea of object inheritance, on the idea of subclassing and mix-ins in order to aggregate functionality for different kinds of objects within the system. And this is, traditional object-oriented programming. It's a very straightforward concept. But the problem is, because Python itself does not support the idea of private versus public APIs, the number of methods and attributes on these objects that were available to developers of add-ons was very large. And some of them really should not have been used publicly, right? Some of them were things that were meant to be used internally only, but they were not separated out. They were not divided from or kept safe from direct use, which meant that over time, people could actually reach down underneath the public APIs and touch things that they probably should not have been touching. The end result, of course, is that add-ons are addressing APIs that would better be left untouched or at least intermediated by some layer of abstraction. And the result of that is because we have a strong support for through-the-web development, many of these kinds of modifications were done on objects that were resident only in the database. Right? No file system code. You've made a modification to something, you customized it through the web. Those customizations live only in the database. They aren't on the file system. And what this means is that those modifications cannot be tested, they cannot be versioned, and because of the distance between where you modified something and where you write about that something, they don't end up being documented particularly well either. Now, to the users who created these things, the problems were not immediately obvious, but at some point the time would come for an upgrade. And you would download the latest version of Plone, and you would press the button for upgrade, and it would appear that everything worked greatly, and you would turn on your website and kaboom, everything would smash on you. There would be bodies everywhere, blood on the floor. And the problem with this, of course, is that what should have been a very simple, very direct upgrade experience becomes a much more expensive and time-consuming operation. And thus, the first cracks began to appear in the careful reputation that Plone had built for itself over time. Now, within the community, the reaction to this was fairly straightforward. If the problem is that when you develop through the web, you end up creating untested, unversioned, and undocumented changes that lead to problems, well then we should prevent you from doing this. This is a habit that you should not get into. So we went into lockdown mode. All of the conferences gave speeches talking about how changes should be resident on the file system. Email messages, support chat rooms, IRC, all of the communications channels moved towards encouraging people to develop purely on the file system rather than through the web. At the same time, work was being done on Zope that allowed for componentization, using a new technology that was called the Zope component architecture. The idea is to use a concept that's called adapters, which we'll talk about in a little bit here, to deprecate these sort of through-the-web customizations using skin layer page templates and replace them with file system-born components, such as browser views. Now, these two we'll get into a little more clearly in a moment here. But this was a change that was happening. At the same time, Python is also moving forward in supporting more complex packaging strategies. This is around the same time that setup tools and pip were being born and brought into life. And so more complex installs, more complex dependency management becomes possible. This complexity supports well the idea of the Zope component architecture, and so the folks who developed Plone and the folks who developed Zope really bought into using Python packaging as their installation strategy. Now, before this change, if you wanted to add a new piece of functionality to your Plone site, you could go to the web, download a zip file from somewhere up on the web, take that file and unzip it into a magical products folder that lived on the file system and restart your Zope server, and boom, you would have the new functionality right there ready for you to use. After this, you had a build system, and you would add the name of the package to your build system, and you would rerun the build, and setup tools would reach out to the network, find the package that you want, download and install it for you, and then everything would be installed. And the benefits to this sort of an approach are clear, right? You get repeatable builds, you get predictable outcomes and reduced surprises, and you get modifications that are completely resident on the file system and therefore have tests for them. They have version control so that you can maintain upgrades over time, and you have the strong support for documentation. But in addition to these benefits, there are some fairly big downsides to an approach like this. Remember that Plone was originally designed for end users, for experimental coders, for people who are meant to come to the website and play around with it and discover their way towards building a really powerful website. And while the end user experience for content creators and content managers maintained its simplicity and its attractiveness, now, in order to extend the system, in order to build in new functionality, you actually had to be a Python programmer. You had to know about Python packaging. You had to be able to write a setup.py. You had to know how to configure your package so that it could be installed by setup tools. And more than that, because underneath Plone is ZOP and the CMF and so on and so forth, just being a regular Python programmer isn't enough. You actually have to be a Plone programmer. So there really isn't a gateway anymore for newcomers. It's much more difficult to get involved. Now, the Plone community attempted to address this through tooling. We created a number of systems for online package creation. You could go to the website, answer some questions, and download a package skeleton that would have all of the boilerplate necessary to create an add-on. You could do the same thing on the file system using a command line tool. But tools like this, they aren't really a solution to the problem. They're just what we would call a Band-Aid on a bullet hole, right? It's just there to stop the bleeding, but really the problem itself still exists. And the message that the Plone community was therefore giving to newcomers was quite clear. We don't serve your kind here. You're going to have to go elsewhere. In truth, though, the idea of hackability, the idea of exploratory coding has really been on the mind of Plone developers ever since this change was made. And over the past few years, a process of evolution has been underway. New packages have been created in the collective that are attempting to address this problem of being able to exploratorily learn how to extend the Plone system, to restore this idea of hackability and a sense of play to the world of learning how to be a Plone programmer. These have been released out into the wild. They've been used by various websites for a number of years now. And this evolutionary process has led to a number of winners. Technologies that have come out on top and have turned out to really restore back to Plone the sense of play that made it such a successful system in the first place. With Plone 5, which was released in October of this year, almost 14 years to the day after the very first public release of the system, we believe that some of these technologies have really resulted in a fantastic, powerful, and thoroughly modern CMS. Now, I'd like to spend the next short while here during the speech talking to you about one of these systems, and to tell you a little bit about the technical trajectory that led to its development. The system is called Diazo, and it's the core of Plone's improved theme story in the Plone 5 series. Now, in order to understand this story, we need to go back again to the beginning of ZOP and understand one of the foundational technologies that lies underneath ZOP. And this is the idea of traversal. This is a URL. I know you all know that. This portion of the URL is the path, right? And in old days, with static websites, things like Apache, this would actually map onto some sort of a file system location. The web server would walk across folders until it found the file that was meant to be served, and it would send that file back to you. This is a fairly straightforward and well understood technical situation. In the world of CGI, it works just the same way, except that at the end there, rather than just a static file whose contents are read and sent back, it's a dynamic script which is executed and then prints its output as some sort of a body for an HTTP response. The magic that Jim Fulton came up with, his basic idea, was to ask himself a question: could we treat Python objects in this same way? If we had some sort of a database that we could instantiate and that we could store objects in as if they were items in a dictionary, could we then extend that with a set of objects that themselves behave like dictionaries, with an interface that allows you to do key-based lookup for these objects? And could we combine those two things to create a system where something like this file system traversal gets replaced by dictionary-based item lookup? Could we change a path like this into a series of dictionary lookups that would let us walk across a chain of containment from one object to another in order to find the object that we actually wanted to publish and show? This is the core of the idea that makes ZOP work. It's an object publishing environment. Now, in order to publish these objects, what we do is we use this process called traversal, taking the path that comes in from the request that has been made from our user on the outside, and we walk across this containment chain until we find the object that we want to publish. Once we have it in hand, we actually call that object. So that object is a callable in Python, and we can execute that, the result of which is then set as the body of a response and sent back to the user. This is a fairly interesting idea, right? If we look at content objects within the CMF, then this call method actually uses a function that's called getViewFor to find the way that that object should be presented to the public. Once that view is found, we actually call the view itself and return that result as the result of calling the object, which means that we can look at the object in a number of different ways based on what comes back from the results to this call for getViewFor. When we drill down a little bit further, what we find is that this getViewFor function actually looks up information about the content object that we're looking for. It looks up a series of actions, and it iterates across that list of actions, trying to find one whose ID matches the name of the view that we've been requested. By default, this turns out to be just, quote, view, right? The string view. Once we find that particular action, then we go ahead and we begin traversing again from the object that we're looking at to that action name to try and find that particular thing. The thing that we get back will then be returned to the user as the callable that's going to be executed in order to build the response body and send it back to the client. Through a bit of magic, this second traversal ends up going into a tool in the CMF that's called Portal Skins. We've seen this before, right? It's an aggregated list of folders that contain things like page templates and Python scripts that can be executed to create some kind of HTML that's going to be sent back, right? And these layers that we have are actually matched up with the action name, right? So inside each one of these folders lives a bunch of page templates. One of them will have the same name as the action that we're looking for, and that one will be rendered. If you want to create a new or customized version, you just make sure that it lives in a folder that's higher up the list than where the original is, and it ensures that your modified version is the one that gets found. The nice thing about Zope is that you can actually customize this through the web. You can go to one of those folders, look up the page template that you're looking at, and press this little Customize button here. Once you've pressed the Customize button, it creates a new copy of that in the database, and you're able to edit it and make modifications to it. But of course, this is where things begin to break down, right? The problem is that page templates have assumptions built into them. What names are going to be available in the context? What values will be attached to those names? Those pieces of information are used to render out a page template and to send a response back to the client. And if the assumptions that are inherent in that page template change between one version of Plone and another, then when you modify those page templates and upgrade Plone, the modifications that you have are suddenly broken. The assumptions that they make are no longer valid, and we have a system that's broken. Moreover, we have a system that's not obviously broken. You can't test for that until you've actually upgraded and noticed that the things that you expect to work are no longer working. Again, the message should be fairly clear. Let's not do that. Let's not make these kinds of changes through the web. And the Plone developers then took this message and decided we're going to move away from doing through-the-web modifications. We're going to move away from trying to make these sorts of changes in the database. We'll use the Zope component architecture to begin to replace these page templates with browser views. Well, what is a browser view, right? This is a question that we need to answer in order to understand this shift. And a browser view is based off of the idea of an interface. An interface is essentially a contract that specifies how a particular piece of software is supposed to work. And these interfaces provide you with an ability to know from the outside what inputs you need to put into a system and what outputs to expect back from that system without needing to care about what the internals of the system actually do, right? You only need to program to the interface. You don't need to care about the actual implementation details. In the real world, let's think about this in terms of like a faucet, a water faucet or something like that. Buildings have a running water system, hot and cold water. Upstairs in my room, there's a thing that looks an awful lot like this with a hot water pipe and a cold water pipe. And we can think of this hot and cold water pipe as the interface to a water supply that happens to exist inside any building. A faucet can provide access to this water supply in a number of different contexts. We might have a kitchen sink with some dirty dishes somewhere that is waiting to be turned on so that we can wash the dishes. We might have a shower stall somewhere that somebody's going to get in and turn on the water and take a nice shower after being in a swimming pool. We might have a washing machine somewhere that we're going to throw some clothes in and turn on, although we probably ought to remove the cap before we actually do that. You can think of the sink faucet, the shower, this washing machine as being adapters to the hot and cold water supply. They provide access to that water supply in a variety of different ways and in a variety of different contexts. We could write some code for the ZCA that would implement these adapters as follows. We can make some imports from the core tools of the ZOP component architecture, and then set up a couple of interfaces that define both the supply and the hot and cold attributes that it will provide, and then the faucet interface, which will allow us to change the temperature of the flowing water and change the rate at which that water is flowing. Once we have these things, we can actually create a couple of classes that will implement these interfaces. The first one here is a house, right? And it implements our water supply. The details of how is really not very important to us. The more interesting one is actually the kitchen sink, which is going to implement our faucet, but it's going to adapt our water supply. And you'll notice that when we adapt something, we take that thing as an argument to our constructor, and we set an attribute on ourself that corresponds to the thing that we're adapting. This is an example of containment, which is a very different approach to object-oriented programming from the idea of inheritance or subclassing that we're normally accustomed to seeing. Adaptation is at its root just containment kind of writ large. So now once we've set up these classes that implement our interfaces, we can go ahead and register them with a site manager. And then when we build ourselves a house, all we have to do is say, hey, well, I would like to have a faucet that is named sink. The object that we get back is going to be one of these kitchen sink objects that we've defined, and we can then use that faucet to turn on our water, change it from hot to cold, and interact with it in the expected way. Browser views are, at their core, just adapters. But they adapt a couple of things instead of just one thing, right? Our kitchen sink adapts a water supply. A browser view adapts two things, both the context, or the object that you happen to be looking at in your website, and the request that was made to get at that piece of content. Those two things in concert are the parts that a browser view adapts. And all a browser view has to be is a callable that can take those two things as an argument and then return some sort of HTTP response as a response. Now, in code, a simple browser view might look something like this, right? We have ourselves a view. You can see that it takes the context and the request as its arguments and sets those up as attributes. And then inside its call method, it uses that request and that context to render out something that it's going to return as a response. This is a very simple example, but I think it helps to get the idea across. We can register one of those things as an adapter using this thing called the ZOP configuration meta language. It's an XML variant that lets you set up and say, for any piece of content, I'd like to have a browser view called my view that is implemented by this particular class. And that points back at the class that we've built to implement this thing. After we've got it registered, then inside our website, we can traverse the request to get to a particular object, in this case maybe the Plone site itself. We can look up a view by asking for the adapter that provides a browser view for that particular object and that particular request, and in the end we can just call that view and get back the string that we're expecting to get. This is pretty exciting and it's pretty interesting stuff. Plone uses these sorts of registrations all over the place in order to provide views now for the content that it has. And since interfaces carry a measure of specificity, you can make interfaces that are more specific than other ones, we actually have the ability to customize simply by changing what we're registering for. Here's our original registration, right? We can add to that registration something that says, instead of for all content, I would like to register a particular view just for this kind of content, one specific type. And then whenever the object that is going to be published is of that type, you get this page template instead of the template that is part of the regular view. That's pretty cool. We can also add a layer to our registration here. And layers are interfaces that get registered when you create a new add-on. So if I create an add-on, I set up a layer. When I install that add-on, every request that's made to my site will be marked with that interface. And if I go looking up views, those views will actually be found preferentially to the default ones that are already in the website. So what do we get as a result of this? Well, what we get is content objects that have a default view name, right? We have this name used all throughout history to look up a view item. The publisher is going to find one of these things by looking up a browser view by that name. It's going to go looking for something that's named view. If we create something named view that is for a more specific content type or for a more specific request than the general situation, we get our customization instead of the general. And so instead of having to put folders into a stacked hierarchy of folders and make sure that our page templates are found first, we get this automated lookup that happens very fast. And the really nice thing is because all of this is implemented using adapters, there's a clean decoupling between the browser views that we create and the stuff that's underneath them. We can write these things on the page, on the file system, they're testable, they're documentable, they're versionable, and we get all sorts of benefits out of them. This is a win. Terrific. Hooray. Except, of course, that now in order to change the view for some sort of a content type, you have to create a Python package. You have to declare at least one class, and probably more than one. You have to write special page templates yourself, and you have to register all of this whole pile of things using, oh, God forbid, XML, right? And nobody likes writing XML. How many of you would raise your hands and say, I would like to spend the rest of my life writing. Oh, there is one person out there, yay! You're the crazy one, right? But that's okay. There always has to be one in the crowd. But the message for the rest of us is clear. Go away. We don't serve your kind here. This is too much effort to ask newcomers to go through. Now, there was a wise man who once said that any problem in computer science can be solved by adding another layer of indirection, right? If we step a little bit further away, we can make all of these problems just go away. So the people who were working on this realized that they'd created kind of a bad situation, and they started asking themselves sort of an interesting question. And the interesting question was, why do I have to override a template? Page templates we have traditionally, in the world of websites, thought of as being layout. There's a one-to-one correspondence between the layout of how our website works and the templates that we use to create that layout. And generally in the web world, in order to change layout, we've had to override or replace page templates with new ones that look a little bit differently. Consider for a moment a thing like a news item. Maybe a news item has itself a title, it has some body text, it has an image that's going to show up that has maybe a caption associated with it. Perhaps in addition to all of this, there's also like a contact piece of information, so somebody can click and write an email message to whoever it is that's organizing or responsible for this news item. Maybe we want to change how that looks. We want to shift it around. In order to do that, in the traditional system, we have to create a new page template that actually changes the layout that we've created. But is this really the only way that it can be? Maybe templates are not layout. Maybe layout is just layout. And maybe we can adapt layout. Maybe we can transform it into something else. Is there a technology out there that we can use to do something like this, to transform layout from one form into another? Well, it turns out that there is, right? It's existed for a number of years, and it's called the Extensible Stylesheet Language Transformation. And the XML fans back here are laughing because they're like, hell yes! XSLT, it's the shit, man. We really love this. It's the best thing in the world, right? The problem is that outside of a very few people who really love the idea of XML, nobody wants to actually write that stuff, right? It's complex, it's difficult, it's mind-bending, and you don't really want to mess around with it. So what we've done is we've created this package called Diazo, the purpose of which is to write XSLT so that you don't have to.
Thank you.
Now, Diazo works with this idea of a theme, which is the way you want your stuff to look, and content, which is how it looks now, right? It consists of 8 separate rules. The first of these rules is this theme rule right here, which designates a particular page template as being the source of your layout. This thing is just an HTML file. There's no magic to it. It has some CSS that's associated with it. Maybe it has some JavaScript that provides functionality, makes the button shiny or hoverable or something like that. But it's just HTML, and it can be written by anybody. Front-end designers, it can be written by the designer that you work with. You don't have to do it as a programmer, which is really quite nice. Now, all the other rules use this idea of selectors to pick out items from either the content that's been created by your CMS or from the theme that sits in the front. And these rules allow you to target particular elements and do things to them. So the selectors that we work with can be either XPath type selectors, which are fun and complex, and for those of us in the audience who are XML fans, they might seem comfortable and happy. For the rest of us, though, there are CSS selectors, which are used by jQuery and a number of other libraries that those of us in the web world are a little more comfortable with and happy using. Your designers understand these selectors, and so they're able to use them quite well and quite comfortably. And Diazo rules then go ahead and use these selectors to do a number of things. In addition to the theme rule, we have the ability to replace items in the theme with items from the content. We have the ability to insert items from the content either before or after items that exist in the theme. We can drop elements from either the theme or content and get rid of both them and all the children that are inside them, and we can strip out tags from either the theme or the content, leaving the children in place but no longer contained. Finally, we can either merge or copy attributes from elements in one onto the same element in the other, which allows us to carry CSS classes and things like that that are signifiers for JavaScript actions from our content out to our templates. What Diazo does is it takes these rules that you write and it precompiles them into an XSLT transform, and then it applies that transform to a Plone site to transform the markup that's created by the content management system into the theme that you actually want to see. And because it's precompiled, and because all of this happens using LXML and really quick libraries underneath, it's very fast, it's very efficient, and it actually works out quite nicely. A theme for Plone 5 then consists of one or more perhaps theme templates along with the CSS and the JavaScript that's necessary to make them work. And then you add to that a rules file that determines how the content will be transformed into that theme. You can use your own tools to do this. If you're working with a designer who loves Grunt, fine. If you have one that uses Gulp, that's terrific. If they like Sass, great. If they like less, okay, no worries, right? We don't have to care about these front-end technologies and about the shifting world of JavaScript and CSS because all of this work is done outside of the content management system. There's no need to have knowledge of it inside the system itself. All you have to do is take whatever they give you, add some rules to it, and upload it to your website and you're ready to go. Now I know, with the exception of this gentleman out here, nobody likes to write XML. And if you use Diazo on its own, which you can, you don't have to use it with Plone. You can install it as an extension to your web browser. There are plugins for Apache and Nginx. You can apply these transforms to any sort of website, a Django website, a Flask website, anything like that. You can also install it as a WSGI middleware, and that middleware can be applied to whatever happens to be generated by your theme. But if you do it that way, you end up having to write the XML rules yourself. With Plone, however, you get a little bit more. There's actually a visible and visual editor that's built right into your website. And I wanted to give just a quick little demo of how this works. So what I've done here is bring up a Plone site, and we can go ahead and we can look at what a Plone site looks like on the front end. And I can make a quick little reload of this. Here is Plone 5, it's all up and it's ready to go. What I'm going to do is transform this website into the PyCon website. From PyCon US, the 2016 PyCon that's happening. What I've done is I've set up a little theme that includes a page template from the PyCon website, and I'm going to go ahead and activate this theme as soon as I can figure out where my little cursor is. Here it is, I'll turn it on. And once I've activated it, I can go back to my front page and reload it, and you'll notice that now it actually looks like the PyCon website, which is, exciting and fun, but at the same time it's not all that great because it means that I can't see any of the actual Plone content, right? This is just the page template that came out of the PyCon website. You see that the navigation bar that is up here includes all of the PyCon navigation bar and not my Plone sites. So what I'm going to do is I'm going to go ahead and actually implement a new rule. I'm going to modify my theme, and I'm going to make it so that Plone's navigation replaces the navigation that's in that website right now. And let's see here, see if I can do this sort of over my shoulder. What I'm going to do is click on this little build rule button right here. First thing I'm going to do is bring up my rules file so that we're actually looking at it. I'll make sure that my cursor is sitting in a place that's nice and safe. And then I'm going to come in here and I'm going to click on this build rule button.
And it looks like I want to replace a rule. So I'm going to say next. And it's going to say, okay, go ahead and look at the HTML mockup and find the thing that you want to replace. So I'm going to hover over one of these navigation bars here and press the escape button until I've jumped up to the navigation bar itself, the thing that holds all the buttons. And I'll click enter to select that. And now it's going to ask me to go ahead and apply or to find an item from my unthemed site that corresponds to that. So I'm going to come down here, scroll down to where I can see sort of the unthemed navigation of my Plone site, and I'll hover over that, press escape a couple times until it jumps up to its full container, and hit enter again. Now, I've gone ahead and I've built a rule, and what I want to do is to say, in addition to applying this to the elements itself, I'm actually going to apply it to the children of those two elements, and I'm going to insert a rule. And you'll see it's gone ahead and written a little replace rule down here that says replace the children of the theme of this navigation UL with the children of the content that are in the portal navigation list item. Once I've done all of this, I can make sure that my thing is saved, and I can switch back to the front end, and you'll see that this navigation bar up at the top, when I reload the page, whoops, is not replaced, which is really embarrassing and sad, but that's okay, because I'm just going to save this thing and make sure that it happens well, and we'll go back and try one more time, and hopefully this time it will do what it's supposed to do. Yes, there we go. So now we've got the actual Plone navigation going on. Because we're running a little bit out of time, I'm not going to take this any further, but we can do the same thing to replace things like the breadcrumb trail that's here, or the content that's stored in the center, the login button, and so on and so forth. And we can do all of this through the web. And when we're done doing it through the web, we can go back to the actual editor here, and we can click on this little back to the control panel thing. And in addition to the buttons that are here to allow us to see the web, to see the theme and to modify it, there's another button in here that's currently not showing that allows us to download this modified version that we have as a zip file. So we can download this theme, we can put the theme into version control, we can write tests against it, we can write documentation for it, and we can then upload it to other websites and apply it to other sites. So we can build themes through the web, but then share them and version them and document them and take advantage of all the sort of best practices that are currently used in modern web development. So this is Plone 5. And Diazo, its new theming engine. There's a lot of other technologies that make Plone 5 worth taking a look at. The first of these is this thing called PatternsLib. The idea behind PatternsLib is we provide a lot of JavaScript functionality. All you have to do is make sure that your HTML markup looks a particular way, and that functionality will automatically be applied. If you want a slider, if you want an image gallery, if you want a calendar, if you want drop-down menus, all you have to do is write the right HTML, and the JavaScript will automatically be applied for you. We have a new content type engine that's called Dexterity that allows you to define content types through the web, but then press a button to export the schemas that define them. You can then take those and put them again into version control. So you can explore in the web, you can try things out there, but then you can apply best practices by exporting all of the work that you've done and making it file system bound, which is a great advantage to you. And with Dexterity, we get this idea of behaviors, which again is adapters. You don't have to redefine the same set of functionality over and over again. If you have a website where you need mapping for a number of different kinds of content items, maybe you're building something for a hospital and you want to make a map of each of the hospital locations. And then later on you discover that you want clinics. And maybe clinics are a little bit different from hospitals, but they also need to be mapped. Mapping can be a behavior, and you can turn that behavior on for content types simply by adding an interface to them, and then those content types become mappable, and the views that show off maps will actually appear for them automatically. This is tremendously powerful stuff. Plone comes out of the box now with a multilingual content engine that allows you to translate all of your content, including custom content types, into whatever language you want. So if you work in a country where you need to have more than one language worth of content available, that's out of the box available to you. There's also an API that's been created for add-on developers. This was initially created as an initiative of a group of engineering students in Eastern Europe who ran into trouble trying to figure out what they should and shouldn't touch in Plone's API, and so they developed an abstraction layer.
we're now using that abstraction layer to separate us out from all the stuff that's underneath in Plone, which is really a good idea. There's a whole lot more, but there's not enough time here for me to go into it. So what I'm going to do is return to this idea of Theseus as CMS. If we've removed all of these old things that made Plone what it is Plone really still Plone? Well, think about it. The idea of Plone was to create something that newcomers could use, that content editors could interact with simply, that you could exploratorily extend and create new and powerful websites without needing to know a whole lot. At the same time, we also want to be able to provide rock-solid reliability, power, security, and so on and so forth. And with all of these new additions that we've made, despite the fact that the engine underneath is very different, Plone itself is still Plone. Based on the work that's gone into this, we believe that we've managed to fulfill that purpose, and so we really do believe that Plone remains Plone, despite the fact that it's what was old is now new. Now there's a lot of work that remains to be done. Plone is not compatible with Python 3 at the moment. There's a great deal of work that has gone into upgrading some of the ZOP and CMF libraries underneath, but there's more work that remains to be done there. If you are a programmer who's interested in writing Python 2 and Python 3 compatible code, this is a great place to get your feet wet and a really interesting project to participate in because it's got a lot of tests and a lot of functional code. If you're not a code author and you rather write things, you're a good author, we also need documentation. A lot of these packages were originally created back in the days before documentation was a core value of the Python community, and so documentation is something that we need a great deal of. Also, as I mentioned before, ZOP is built on top of a number of other layers. Those layers are technology that not a lot of people are using anymore. ZOP is basically dead at this point, and the CMF is as well. Nobody else besides the Plone folks are using it. So what Plone has done is to fork these libraries and take control of them. And there's ongoing efforts through a number of sprints to take all of those layers and simplify them, and begin to cut down the amount of stuff underneath us to make it a little bit easier to move forward into the future. Contributing to an established open source project is known to be one of the best ways to enhance your career and to advance your skills as a developer. And the Plone community is a healthy, strong, and vibrantly international community that welcomes newcomers. We are built on a tradition of sprints. We have more than a dozen of them a year, and they're happening in places that are relatively near to you. You're almost be able to find one. We have a strong and well-enforced code of conduct, so it's a safe and welcoming space to come in. And we are so accustomed to working with people from other countries and in other languages that we're very comfortable in bringing you on board and helping you learn how to be part of this group. There's over 300 core contributors now with people who have rights to build the core of Plone. And in the collective, there's nearly 500 people and 1,500 add-ons that are ready to welcome you in and be part of it. Can we join your name to the group of people who are using Plone? If you're in the market for a new CMS or you're working on a project that has a content management aspect to it, I urge you to take a look at Plone as one of the options that's on the table for you. We know there are other options and we'd like you to look at them as well, but I will assert that you'll not find a more powerful, feature-filled, or secure CMS than Plone anywhere in any language. If you have decision makers at your company who are responsible for choosing the technology that you do, point them at this website here. It's the one that contains information for those types of people. And I'd like to give some thanks as I close up this speech. The first is to our PiterPy organizers who invited me to come here and have asked me to be a part of this conference. I've enjoyed the heck out of it, and I'm really looking forward to the rest of today. I'd also like to thank Eric Steele and Paul Rowlands, who are sort of at the head of the Plone community and help to keep the community vibrant and alive. I'd like to thank Brandon Rhodes, who is the organizer of this year's PyCon, who gave me the idea of giving this talk in a late night drunken chat session once upon a time. And then I'd also like to thank a number of members of the Plone community by name, whose conversations really contributed to the ideas that make up this particular presentation. There are a couple of additional credits here for some of the images that don't have credits attached directly to them, and I would be deeply remiss if I did not point out that we're having a conference in 2016 in the city of Boston in the United States, and I would love to invite you to it. I'm one of the organizers for that conference. There will be 2 days of training included in the price of the conference, so you can come and learn about Plone, and there's also 2 days of sprints after the 3 days of talks of the conference so that you can actually participate and kick into the Plone
community. Once again, my name is Cris Ewing. This is my contact information, and I'd love to take any questions now or in the hallway track in between this and the other talks. I'll be here all day, and I'm looking forward to chatting with you all. Thanks.
Thanks, Cris. Impressive. Yeah, we have a little time for several questions. So I will also ask you something provocative.
Hi, first of all, I want to thank you for this broad overview of the Plone. It was interesting and I learned a lot. Yeah, you said a lot on templates, themes, and this is really fascinating to see how they work in Plone. But what about, we live in a RESTful world now.
Yes.
How is it connected with all that technologies that we use now and like to use now?
So because the engine that we use for doing page templating is based on adapters, and because those adapters can adjust themselves to different attributes of a request, it is possible now to write response or template views, not template views, but browser views that are intended to respond to RESTful queries, right? If we're making a query that's based on a REST API, we can mark that query with a particular interface, and that request that comes in with an interface on it that says, I am a RESTful query, will get a response and a browser view that's intended to produce JSON and to produce a reply that's adapted to that. In fact, there is now under development a REST API package for Plone that works exactly on this principle, that requests that come in are marked with a particular interface, and then you can write browser views whose purpose is to produce JSON or produce RESTful responses rather than producing sort of page template type responses. So yeah, that's a great question, and we're trying to look forward to this world and participate in it enthusiastically.
Yeah, thank you.
You're welcome.
Hello, two questions. The first one, this diazo package, can it be used for conversion other XMLs, not HTML, not page templates, but some, but to create some transform between two XML files?
I would imagine that the answer to that is yes. Right? It does depend on a valid document type definition, so you have to have valid XML coming in and going out. And because the rules are based on replacing elements and replacing attributes on those elements, I think those are generalizable. You might not use the CSS selectors, you might use XPath selectors to find the elements that you want, but I believe that it would be possible. I don't know the answer to that specifically because I've never tried it myself, but I do know the person that I can put you in touch with who would be able to answer that for you.
Okay, and the second question is, what about performance of Plone?
The performance?
Yeah.
Okay. It is actually not that bad. It's not...
Okay.
It is not lightning fast, right? But it is used to power some really, really large websites. And because it plays along with the idea of server-side caching, because it plays along with a number of other HTTP acceleration technologies, and because it has adapters built into it that will help to facilitate that kind of stuff, you can actually tune it to be extremely performant. There was a talk at a Plone conference 2 years ago by Dylan J. He's a developer who lives in Australia, and he's set up a website using Plone that was for the emergency response system for New Zealand for their earthquake center. And when they had the big earthquake that hit a couple of years ago, the traffic on that site jumped, immediately sky high, and Plone actually handled that well. It was deployed under AWS with an automatic scaling option so that it was able to expand itself out. The engines that we have in the background that adapt to the ZODB, you can actually take the ZODB off of the file system and put it into a Postgres database or another relational database. The nice outcome of that is that you can then balance across multiple database backends that are mastered together. And so it's possible to set up a highly available, really performant ZOP and Plone cluster.
It has been done, the engineering is there and available to you.
Okay, thank you very much.
Okay, yeah, and then my question. As a programmer, I'm a very lazy guy, and I don't want to spend too much time to installing things. And currently, during your talk, I tried to do a pip install Plone.
Nope.
Nope.
No.
Okay, yeah,
It
it's
comes
not working.
No, and it won't work. Actually, that's not entirely true. There actually has been some work done recently on being able to do pip install Plone. The problem is that the dependencies that Plone has and the complexity of those dependencies are such that pip is not really up to the job. It has been improved a great deal now, so you can create a requirements.txt file that's sufficient, but at the moment to install Plone there is an installer that you download. We use a different installation system called BuildOut that was invented by the Zope community. And actually BuildOut is a badass piece of technology. It is a really great and powerful build system, and it does a lot of things that pip is just not capable of doing. But we recognize that it's not the direction that everybody else has gone, and so we are working on trying to make things more pip installable. But we do have now support for Docker containers. There are Docker images for Plone. We have AMI instances for Amazon that you can use to set up a Plone site and get it running quickly. And for the upcoming Plone conference, we're planning on having a deployment contest where we have different people in the community come up with new deployment strategies and have a contest to see both how quickly they can get Plone sites set up and also how they can take the deployment system that they've created and have a newcomer come up on stage and deploy without knowing anything about it. So we're working very hard on trying to improve that story.
Yeah, thanks. Okay, then I think we will continue in the not official way. So thanks. We need to make some break and prepare the next speech. Thank you, Cris.
Thanks very much,
Incredible.
everybody.